Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the use of a SHA file hashing routine to uniquely identify a file. So what is SHA or SHA? The secure hash algorithms are a family of cryptographic hash functions. Cryptography itself is defined as the art of writing or solving codes. So what can you use it for? Well, surprisingly, we are not going to do anything with blockchain or cryptocurrencies. We're going to use this for file identification. Let us assume for the moment that we are writing a program that needs to take in data on a periodic basis, perhaps daily or even hourly. This data is presented to us in a file format, and we are required to feed this data into a system. What would the stages of a processing actually look like? Well, first of all, we would need a mechanism by which we could detect that a new file had been presented to us. Following that, we would need a mechanism for validating the contents of the file, as it's much easier to stop bad data from getting into a system than handling bad data once it's actually in a system. Next, we would want to process the contents of the file, and these would feed into our system. So there are a number of challenges in this approach. First of all, how would we know whether the new file was actually new? Have we seen the file before? In such a system, you may well insist on a naming convention for the files. The files may be coming from another system, in which the data is strictly controlled, or the data may be coming from users. And in any system that involves human input, there's always the danger of errors creeping in. So we will want a nice, easy, straightforward way of identifying that the contents of a file have not yet been processed, and in fact that the content of a file is something we have never seen before. And that's what we're going to look at today. So let's have a look at some code. If we're going to look at the processing of files, first we need a file to process. We're going to use our Generate Data application we wrote several videos ago. This is now set up to generate 1000 randomly generated records. And there we have our test data file containing 1000 records. So we're going to copy this file and we're going to paste it into a data folder. And this is a file we're going to process. So since this is a CSV file, we're going to set our application up to look for CSV files in the data folder. And for each file it discovers within that data folder, it's going to check to see if we have already processed that file already or not. So we're going to add some new libraries to our application. I'm going to cover what each of these libraries does later on in the video. But we'll push on now with the processing. In order to determine whether a file has been processed or not, we're going to use these libraries to generate a 32-character string. This string will be held in a file. We're going to call that file hash record. So we will create a constant to hold the name of that file. As our CSV file is going to sit inside the data folder, we will first want to scan that data folder for any CSV files. And we'll be using the dir command to perform that function. We're giving the dir command the path of our executable plus the data folder. And we're looking for all files within that folder that have the CSV extension. And we're going to do a while loop. This loop will run continually until there are no more files to be detected. Before we set up our processing, we will first check that the while loop is working correctly. This should populate the file name variable with the first file it finds. If it can find no file initially, the while loop will not execute because the while loop will only run while the file name is not blank. If it has actually found a file, then we will print the name of the file to our log. We will then look for the next file and the loop will continue. If we try running the application now, it will report this single file we have detected, the testdatafile.csv. So our while loop is working correctly. We next want to create a function to determine whether the file we have just picked up has already been processed or not. So we're going to create two additional local variables, an strError variable to hold any error that occurs, and a file hash variable to hold the 32-character string, which is an identifier for the file. And we're going to pass these parameters to the new function we're about to create, called processFiledAlready. This will take the name and the path to the file we wish to process, the error variable, which can return an error should one occur, and the file hash, which will be coming back from the routine as well. And we will write to our log to say whether the file has been processed already or not. So let's look at creating this new function, processFileAlready. The purpose of this function is to determine whether the file has already been processed or not. So we will create three local variables to keep track of this information: a string array, a string variable, and a long variable. And we're going to assume that the file has not already been processed, so we'll set the function initially to false. Now we're going to call one of the functions in the libraries we added at the beginning of the application. This is the funGetSha, which takes a single parameter, which is the name and the path to the file. We'll cover this function later on in the video, but the purpose of this function is to return a 32-character string. This hash value is a unique identifier for the content of the file. Should there be any issue in returning that value, then the string will have the words unable to hash in it. So we'll test that first of all to see whether the hash generation has been successful or not. So if the words unable to hash are in the string that has returned, we can assume that an error has occurred. So we will pass that error detail back to our calling routine. If those words do not exist in the string, then the hash has been generated. So we now want to check to see whether this hash value is in the file hash record. So we will use one of the routines we've used many times in our file handling library, the read the file into an array. It will take all the data that exists within the hash file record and pulls it into an array. Since this is our first run of this application, this hash file record will not exist. But if that's the case, that's fine. We will just return the hash that has been generated. But if we do have a hash file, then we can scan that using the array scan command. This is looking for a match for these 32 characters. If we find an entry in this array, then we know the value has been found and we have already processed this particular content of file. So if the value put into a long index is greater than 0, then the item has been found. If the value passed back from array scan is 0, then the item has not been found. Either way, we will pass back the hash value we have been given. The only difference being, if the index is greater than 0, we will return true. Otherwise, we will return false. So now we have the kernel of our application operational. Let's have a look to see how it runs. Well, it's giving us in the log a message to say it's processing testdatafile.csv. It's checking the file hash record. The file is not found because we have not yet created the file hash record. So as such, this file cannot yet have been processed. So we look back to our PB main function where we called the processed file already. If the file has already been processed, then we do not wish to continue. If the file has not been processed, we can go ahead and process the file as long as there is no error message. So if the strError variable is currently unpopulated, it means we can continue processing. And following processing, we can then save our 32-character file hash to the file hash record. So we can do that quite easily using another inbuilt function of our file handling library, the append to file. This takes a mere 2 parameters, the first being the path and the name of the file we wish to create or write to, and the second being the value we wish to write to it. So this would write the value into our file hash record. And if for some reason we were unable to hash the file, the str error variable would be populated. So we can write that out to our log. So let's try running that application now. So it is correctly picking up the single CSV file, it is generating the file hash, it's identifying that the file has not yet been processed, and it's updating the file hash record. So if we look in our folder, we can see there is now a new file called filehashrecord.txt. If we open that up, we can see we now have a 32-character file hash record. This is unique to this particular file content. So now that we have generated this file hash, if we attempt to run the application again, what should happen is it will generate the file hash, detect that the file hash is already in our file hash record, and then not process the file. So let's try running it now. And in our log we can see that it has identified that the file has already been processed. So if we have a scenario where someone has uploaded a file for processing, we have successfully processed it, and then perhaps someone else in the team has uploaded the same file again, possibly with a different name, but the same content. Would the system handle that? If we go to our data folder and we change the name of the file. Now we have changed the name of the file, but we have not changed the content. If we go back to our application and run it again, it would still say that the file has already been processed because the content of the file has not changed. If we open the file and make a change to the content of the file, the file name has not changed since the last time the program saw it, but the content of the file has actually changed. If we run our application now, it comes up to tell us that the file has not yet been processed, because as far as the file hash is concerned, this is a different file. The content is not the same. If we have a look in the file hash record, we'll see that we now have an entirely different file hash for this particular file. So even making a one-character change to a single file will change the file hash that is generated against that file. However, even if you change the name of the file or the date and time which the file was created, it will still generate the same hash record because the content of the file is exactly the same as it was before. So we now have a very easy mechanism by which we can determine the content of a file and whether it has changed since the last time we saw the file. So if we generate an entirely new file, and then we copy that file and paste that into our data folder, we now have two files, test data file and test data file copy. If we run our application again, it recognizes that we have two files, a test data file, which is not yet processed, and it has updated the file hash record for that, and a test data file copy, which it has already processed. So you can use this mechanism quite easily to determine whether files have been done already or not. So how was this file hash actually generated? Let's have another look at the code. As you will see in our process file already function, there is a function underlying that which actually does the getting of the file hash, the funget_sha. The functions we're about to look at were created quite some years ago, and a number of people other than myself have actually worked on them. So to return the hash value of any file, this function is called. The funget_sha function is going to return the hash value of any file. It takes a single parameter, being the path and the name of the file we wish to look at. It then opens the file in binary mode, shared just in case something else has got a lock on the file, and loads the entire content of the file into a string variable. We're then passing that string variable to another subroutine, and we're getting back this variable here, SHA-1, and this is a user-defined type. As you can see from the top of the application, it's effectively 5 long variables. We're then passing that to a tsha and then to a SHA base 16 to base 32 subroutine. The tsha converts these 5 long numbers into something that's a little easier to actually see, using the hex $ command. These functions have been designed to work on fairly large files. And in order to calculate the SHA value in a reasonable amount of time, some of the code is actually run in assembler. This is one of the strengths of PowerBasic, that should you need to step down and use inline assembler, PowerBasic gives you the facility to actually do that. Any code line starting with an exclamation mark is effectively you keying in an assembler operand. It's probably fairly rare that you would actually need to step down and use assembler, but it's good to know that the facility is always there should it be needed. In this case, assembler is used in order to calculate the hash as fast as humanly possible. This approach in generating hash numbers for files in order to determine whether the file has indeed changed or not is also used by things like virus checkers, to see whether a binary has actually changed since the last time it was scanned. Using this approach, it does make it much easier to determine whether a file has indeed been seen before or not, regardless of the type of file. You don't have to put any special handling in, you merely have to call the routine and get the hash number back. And once you have determined that the file has indeed not been seen before, you're then free to do additional validation on the file and then import it into your system. Hopefully you'll find these libraries and functions useful in your applications. But that's it for today. Thank you for watching.